As we have discussed in last video that of pressure dimension, now the dimension of resistance. As we know that voltage is equals to current multiplied by resistance. Resistance is equals to voltage divided by current. So as we know that voltage, the dimension of voltage is ml2 t minus 1 a minus 1, and this current is noted by ampere as a. So the dimension will be ml2t minus 3a minus 2. This a will convert into minus 1 power, so it will be a minus 2. Now the dimension of kinetic energy. As we know that kinetic energy formula is 1 upon 2 mv square. 1 upon 2 is a numerical, so we will not consider, we will simply neglect it, and mv square, m will be denoted by capital M, and we have already calculated that lt minus 1 is equal to v. Here v shows that velocity, and here's a square, so L square t minus 2 square, it will be the dimension of kinetic energy. Now the dimension of density. The formula of density is equal to mass per unit volume. As we know that the dimension of volume is L cube, and the mass will be noted by capital M, so it will be, when this minus 3 will come up in the numerator, it will be minus 3 power, so ml minus 3 is the dimension of density. Now the dimension of moment of inertia. The moment of inertia is equal to I is equal to mr square. Okay, I is equals to m is always denoted by capital M, and r square means length, and multiply by 2 because it's a square, so L square. Now stress is a force, we can say. So it's this formula of stress is force per unit area. The dimension of force is mlt minus 2, and the area of dimension is L2. When this positive L2 will come in this plus 1, so it will be plus 1 minus 2. So here you can see L is equal to plus 1 minus 2, and T same as a minus 2. So minus 1 plus 2 will be minus 1. Now surface tension. The formula of surface tension is equal to F is equal to Kx. As we know that we have to find K constant, so K is equal to F upon X. X denoted by the distance we know, we will denote by the capital L. So K is equal to, we know the dimension of force, we will put here, and distance is denoted by capital L. This L will be divided by L, cancellation, and m t minus 2 will be the dimension of surface tension. Angular impulse. The formula of angular impulse is force into time. We will put the dimension of force, and here will be the writing dimension of T, capital T, mlt. This has the positive power 1, so minus 2 plus 1 will be minus 1. Okay, now angular momentum. As we know that angular momentum is equal to mvr. Here m is mass, v is velocity, and r is length. L is equal to mlt square t minus 1. And now centripetal acceleration. As we know that centripetal acceleration is equal to velocity square upon r square. We know that velocity is equal to lt minus 1 square upon L square. Radius is equal to L is because it's a length. So L square t minus 2, and L same. 1 L cancel with 1 L. 1 L is remaining here also. So lt minus 2 will be the acceleration of centripetal acceleration. Now gravitational constant. As we know that F is equal to G m1 m2 upon r square. We have to find this constant G, capital G. So we will do cross multiplication as F multiplied by r square, and this will be formula. So we have to find capital G as a constant. G is equals to, here m1 m2 is multiplying with G, here it will be dividing, and force will be multiplied with G. So as we know that force is mlt minus 2, and radius is length, so we will denote it by L. It's a square, so it's a square. And m1 m2, it's a mass of means mass 1 and mass 2, so m multiplied by m. 1m cancel with 1m, it's remaining 1m. L2 plus 1, okay, plus 2 and plus 1 will be plus 3, and t minus 2, m minus, because it will be converted into this numerator value, so m minus 1 t minus 2 L2, okay. L will be cube, L cube, because this positive 1 and positive 2 will be positive 3. Now the dimension of weight is equal to mg. M will be denoted at a capital M, and G is equal to G here is telling us about gravity. That gravity, or we can say that acceleration is equal to LT minus 2. So it will be the dimension of weight. Now power of length. As we know that power of length is equal to 1 upon focal length. Focal length is basically a distance, so we will represent it by means capital L, so it will be P is equal to L minus 1. When it will be coming in the numerator, it will be minus 1 power, okay. Strain has no unit, because strain is a ratio between length into length, being distance upon radius. So we'll write simply here L into L, they will cancel each other, and there is no dimension, means m0 L0 T0, no dimension. Now angular velocity, this is omega constant is equal to theta upon t. This is a formula of angular velocity. So as we know, omega is equal to 1 upon t. How 1 upon t? That theta is equal to 1. So when we move this t upward, so it will be minus 1 power. So the omega is equal to t minus 1. Okay, here theta is 1 because theta is equal to distance per r, means distance per radius. So distance is denoted by L, radius is also denoted by L. It will cancel each other, and 0 will be dimension, so we will write as 1. Charge, as we know that current is equal to q upon t. Here q is a charge, okay. So we have to find charge is equal to I into t. I is represented by capital A, because the unit of ampere, and T by capital T. So the dimension of charge will be AT. Now dimension of friction. As we know that friction is a force, so it will the dimension of friction will be same as the dimension of force. Coefficient of viscosity, as we know that the formula of viscosity is this: 6 pi eta RV. 6 pi will be neglected because it's a numerator, it's a numerical, so it has no dimension. We will simply neglect it. We have to find this eta, so eta is equal to F RV, okay. This will be RV. We have neglected 6 pi, okay, because they have no dimension. So force is equal to M LT minus 2, and R is equal to L, and V is equal to LT minus 1. So L minus 1L and 1L will be cancelled. 1L is here remaining, so it will be M L. Here 1L is remaining, so it will be minus 1L, and T minus 2. This minus power will be adding in this, so minus 2 plus 1 is equal to minus 1. So M L minus 1 T minus 1 will be dimension of coefficient of viscosity. Now frequency is equals to 1 upon time. So as we know that this is a positive t, it will when it will come in the numerator, it will be minus t minus 1 power, because here it is dividing, here it will be coming in the upward side, so it will be minus power, it will be minus 1. Okay, so it was the dimensions, all of the basic formulas that we have done.